Divide rational expressions. Before we get into dividing rational expressions, I want to start just by remembering how we divide regular fractions. So for example, if I had 16 over 15 divided by 2 over 27, what would be our strategy for dividing this fraction? And the answer is flip and multiply. And so if it's been a little while since you've seen this, we're going to flip the second fraction and multiply instead of divide. So 16 over 15, instead of divided by 2 over 27, it's equivalent to or equal to multiplying by 27 over 2. And that's a mathematical rule that we could prove that, or you can go look up a proof of why it's true, but instead of dividing by a fraction, it's equivalent to multiply by the reciprocal or flip of that fraction. So we're going to go ahead and do that. So now we just have a multiplication problem, and in multiplication we would just multiply the numerators and multiply the denominators. But before we do that, we should cancel anything that's in common to make our lives easier. So looking at this, 16 and 2 have a 2 in common. So I'm going to divide each by 2, and that leaves me with 8 where the 16 is, and 2 divided by 2 is 1. And then the other two values, 15 and 27, they have something in common. They have a 3 in common. So dividing each by 3 leaves me with 9 up top and 5 on the bottom. So this 16 over 15 divided by 2 over 27 is simplified quite nicely into a multiplication. We've done some canceling, and now we just have to finish off by going 8 times 9, which is 72, divided by 5 times 1, which is 5. And so we're actually going to be using the same strategy for dividing rational functions, or rational expressions, I should say. And I'm going to show you how to do that right now. So here we go with our first example. We're going to divide these two rational expressions. And just as we talked about, rational expressions are just fractions with polynomials. So to divide them, we can apply the same rules that we know about with fractions. So we're going to flip and multiply the second fraction. So this looks like rewriting the first polynomial here, or the first rational expression. Now there's some factoring we can do, but I'm going to do that in the next step. So there's our first rational expression, and then we're going to multiply by the flipped form of the second rational expression. So 6 over p squared minus q squared. And now we're ready to go ahead and multiply these two rational expressions. And so we've worked on multiplying rational expressions in the past. What do we have to do? We have to factor and then cancel. So let's go ahead and try our factoring. So the first expression can be factored into p plus q times p plus q. And in the denominator of this rational expression, we can factor out a 2, leaving us with p squared plus pq plus q squared. But looking at this rational expression here, we actually can't factor it further. So that's as far as we can factor that that polynomial there. Then we have multiplied by 6 over, and in the bottom here we have a difference of squares in this rational expression. So that would be p plus q times p minus q. That's our difference of squares. And now that our two rational expressions have been factored, we're just going to look for common factors. I've got a p plus q and a p plus q. And I also have some commonality in the numbers, so 2 can be canceled up here with part of the 6, leaving us with 3. And that's all that cancels. Because this this polynomial in the bottom of the first rational expression can't be factored any further, then we're done. So now we just go ahead and multiply. Well, so I have p plus q times 3 is just 3 times p plus q on the top. And in the bottom, I just have p minus q times p squared plus pq plus q squared. I could have written those two brackets in any order. It's just my math teacher instincts that I like to write the smaller factor first, so I wrote the bracket of p minus q first, but that's all that was. You could write those two brackets in the denominator in either order. But that's our completed division problem. In this next problem, it looks like a giant, totally messy fraction. But what we're going to do is we're just going to rewrite it as a division problem. And we're going to see that it doesn't look so bad after that. So here's the numerator of the fraction. So this numerator of the larger fraction I've just transcribed out. And division is just another way to write, or I should say a fraction is just another way to write division. So really, if we have this fraction divided by another fraction, then I can just write it out as a division problem. I have the top fraction divided by the bottom fraction. And the reason I'm doing this is because now all of a sudden the problem doesn't look so bad. Now it looks very similar to our last one. It's just a couple of regular rational expressions, and in order to divide those rational expressions, I'm just going to flip and multiply. So rewriting that first rational expression, I'm going to take the second and flip it and multiply. And now I'm back on track, ready to complete this problem. So even though it looked really messy, really daunting at the beginning, it's really not that bad. It's just a matter of now factoring and canceling, and it's the same process we've done a couple of times. Now these polynomials are going to be factored by different strategies. This first one is what we call a messy trinomial. So we have to use whatever method we're comfortable with to factor it. And I'm just going to jump ahead to the factored form. So 6x squared plus 7x plus 2 factors into 2x plus 1 times 3x plus 2. And I'm just jumping ahead to that so that we can save some time. On the bottom, there's a factor of 4. So that's 4 times x minus 2. And then the second fraction, at least on the top, we have a simple trinomial. So this is going to be x minus 2 times x minus 3. And on the bottom, another messy trinomial, which would be 2x minus 1 times x minus 3. And now it looks like we have a bunch of common factors, which is really good. So let's cancel what we can. I see a x minus 2 and an x minus 2. And I see a x minus 3 and an x minus 3. And that looks like it. I think that's all we can cancel. So our final answer is going to be what we have left on top, 2x plus 1 times 3x plus 2. So nothing canceled from that one, interestingly. And on the bottom, we have just 4 times 2x minus 1. You don't have to multiply that numerator or the denominator back out. Leaving your answers in factored form is totally acceptable, and in fact, in many cases, that's the best way to do it. It's a very clean way to write your final answer. So feel free to leave that final rational expression in factored form.